Hi class. This is the setup for tomorrow's lesson that I really want you to watch tonight, to take a look and maybe even start the back side of the worksheet that you got today. Simplifying rational exponents. Remember, rational means fractional, and fractional exponents just means it looks something like this: x to the 1/3. That's an example of a rational exponent. So now we're going to have more than one rational exponent, and we're going to figure out what to do with them. Let's try. So let's start with something you already know. If I have x to the 5th cubed, okay, let's think about what this means. X to the 5th cubed means I have x to the 5th 3 times. So x to the 5th times x to the 5th times x to the 5th. And we remember from the rules before that if you have like bases and you're multiplying, then you're just adding the exponents. So that's 5 plus 5 plus 5 is 15. And then we learned the actual shortcut is if you have a power to a power, you are multiplying the powers. Same rule applies when it comes to rational exponents. I have a 5, x to the 5th, but now raised to the 3/10 power. So let's write this out. I'm going to go 5 times 3/10. Well, let's put this 5 over 1 and see what we can do. Anytime I have fractions, I should always look to see if I can do any cross-canceling. This 5 turns that 10 into a 2, so I end up with x to the 3/2. My fraction is reduced. I'm good to go. And just for extra practice, let's just write this in radical form. You don't have to do it for tomorrow's worksheet, but for those of you who weren't there today in class, you need to know how to do this. So the denominator is my index. The base is my radicand. And then my numerator can either go here next to the 3 under the radical, or it can go outside the parentheses. Either way is fine. Okay, let's try another one. Okay, so now I've got two things inside my parentheses. Remember, when I have the power rule, it's kind of like distributing, but a power can only go to another power. The power to that x25 is a 1. So remember, it's going to be a 25 squared, and then I'm going to multiply those exponents. Do not do 25 times 2. That's one mistake a bunch of people make. The other mistake is they'll only multiply the 2 and the 8 together, and they'll forget about the 25. But if 25 is in the parentheses, you've got to take care of it. Okay, and so that's not fully cleaned up, so 25 squared is 625, and I get x to the 16th. Okay, so that's what you already know. So let's apply that problem to a fractional exponent. Same rule, that's a 25 to the first power. I get 25 to the 1/2 times x to the 8 times 1/2. Let's clean this up. 25 to the 1/2 is the same as the square root of 25. Let's just write that off to the side. This is the square root of 25. Since it's the square root of 25, then that first part cleans up to a 5. And then I have x, 8 times 1/2 is a big 4. And that's it. No more parentheses. I gave the 1/2 power to all the powers on the inside. Everybody's cleaned up and I'm done. Let's do another one. Okay. So now let's try two similar looking problems. The first one, I have 81 x to the 12th all to the 3/2 power. So just like the problem before, my 81 is to the first power. So let's distribute that. 81 to the 3 halves, and then x to the 12 times 3 halves. We'll clean that up in a second. Okay. Well, 81 to the 3 halves, I bet that cleans up even more. So let's write it in radical form and see if we can figure it out. 81 to the 3 halves power is the square root of 81 cubed. Okay, and then my 2 turns this 12 into a 6, and I get x to the 18th power. Okay, now I just got to clean up that square root. The square root of the square root of 81 is 9. Write that in a different color. And so 9 cubed, 9 times 9 times 9 is 243 x to the 18th. That is our perfectly, completely simplified answer. Okay, so what if you see a decimal? Is a decimal a rational number? Yes, it is. If it can be expressed as a decimal or a fraction, that means it is perfectly legal. I personally like fractions better because then I can do some cross-canceling. So 1.25 as a fraction. 1.25 is 1 1/4. 1 1/4 is 5 quarters. So we're going to rewrite this problem. 81 x to the 12th to the 5/4 power. And now we're just going to clean it up like we did before. 81 to the 5/4, x to the 12th times 5/4. Let's cross cancel where we can. The 4 turns the 12 into a 3. 81 to the 5/4 power. Okay, let's bring down my x so far. I have x to the 15th. So now, let me go to a new page and let's do 81 to the 5/4 power. And we'll go back. Okay, if I write this in radical form, I've got the 4th root of 81 to the 5th. Let's see if we can factor tree this. 9 and 9. And then I have quadruplets of 3. Perfect. That's exactly what I want. I have an index of 4, so that means I'm going to pull out identical 4 numbers. I have no leftovers. So this turns out to be a single outside 3 to the 5th power. 3 to the 5th power is 3 times 3 times 3 times 3 times 3, which is 243. So let's go back to our previous problem. And we now have our final answer, 243 x to the 15th. Okay, and then we're going to do a little bit more with product rules and negative exponent rules and stuff like that. But the power rule is the most important one that I want you to get a hold of for tomorrow's class. Thanks for listening. 9 minutes of your life you'll never get back. I'll see you tomorrow. Bye.